So in all the JEE Mains papers that we have seen, there is one problem which actually just looks like how do we actually solve this. I mean, students have no idea about how to go about solving that one problem. Now this can be one such problem in which the students really don't understand how to which kind of formula or what would be the approach, whether it's the AP, GP, HP, what kind of thing do they use to actually find this sum of this series. Similarly, other problems in the previous JEE papers we have analyzed, and we have found a lot of problems which involve the fourth power. Now this fourth power is actually becomes very important, and you would have seen too if you have joined our doorstep tutor course. We have solved several such problems, but the common theme across all such problems is this one identity, which is the Sophie Germain identity. Now this identity allows us to break the fourth power of two numbers, allows us to factorize it into these two components. Now you can easily prove it by going from here. If you simplify this expression on the right hand side, you will get the LHS and you can prove it, but let's just try to prove it going from here to here, okay? Because these are just numbers, we just cannot trust them. These are just letters, okay? So let's just prove it and give them some meaning. So the way we'll prove it is, we'll see that this particular number a raised to power 4 is actually can be written as a squared the whole square. So this is our square, the first number is square, and then this can also be written as a square. So this is the second number square. Now we know that a square plus b square, what is missing is 2ab. So that becomes 4a square b square minus what we'll write it, this should be square here, okay? Then this is minus 4a square b square, okay? So we have added this and subtracted this, so the expression remains neutral. And now of course we know that what this is, a square plus b square plus 2ab. So this becomes a squared plus 2b squared the whole square minus 4a square b square. Now this 4a square b square can be further simplified. So this becomes a square plus 2b square the whole square minus 2ab the whole square. So this is a square minus b square, or x square minus y square formula, which is equal to x plus y into x minus y. So x plus y will be 2b squared plus 2ab, okay, so far so good, and x minus y will be plus 2b squared minus 2ab. Now this we can easily now simplify it. We can see some simplification scope here. Now this b we know can be broken down into two b's. This is b squared plus b squared, and similarly we can do it for here also, b squared plus b squared. So this becomes a squared plus b squared plus 2ab, which is a plus b the whole squared plus, now what is remaining is 1b squared, so that will still remain, it cannot go anywhere, multiplied by, here we will have a minus b the whole squared plus b squared, okay? So we have proven this Sophie's identity. Now of course you can read more about Sophie Germain's identity. Those of you who are preparing for International Mathematics Olympiad or the RMO Regional Maths Olympiad, who are preparing with, we have already discussed this in our doorstep tutor lectures, but these problems are also now being asked in the JEE, so it becomes very important for us to actually look at some of these. So now in this problem, how do we apply this identity? Now that is the real question. The other problems that I have shown you in the beginning, we'll solve them on this channel, so stay subscribed and look for the notifications. But this particular problem, how do we actually apply? Let's just try to apply it here now. Now one of the other things, basic knowledge that you also need to have, and those who are again taking a course with me would already know this, but for others, let's just make sure that we are on the same page. So one of the things that whenever we have the sum of these terms, we need to add certain fractions like this. We always try to express each of these terms in this form, okay? And it is very important that we understand this. So we are expressing it in the form of a plus b minus c plus d divided by, from here we will have a plus b into c plus d. Now this alone would not really help us, but combined with the next term, we really have magic. So c minus e plus f, okay? So So bottom, we need to factorize this into two portions, into two factors, and at the top we have the subtraction of those two factors. Now that is the common theme. It's not very difficult to understand once you get it. And at the bottom, of course, we will have from the second term, this is what we get two fractions. Okay, now it is very easy to see that these fractions can now be broken down as follows: 1 by a plus b into minus 1 by c plus d plus 1 by c plus d minus 1 by e plus f. Okay, now this is the c plus 1 by c plus d coming from the first term, and the second term gives us a positive 1 by c plus d. So these actually do cancel. Okay, similarly from the second and third term, these would actually cancel. Okay, and so on and so forth. So ultimately, when you do this telescopic sum, you will be left with one fraction, the first fraction from the first term, and the last fraction from the last term. That is what you will be left with, and you only have to find the difference of those two to evaluate the sum. Now this is the common technique, again I am saying, and we should be able to use it in very many problems, and we have been solving those already. So now the trick here is actually to be able to use this identity to break the denominator into two portions. Now let us see how we can do that. So for that, what we'll do is that we'll first try to express this these terms in this format: a raised to power 4 plus 4b raised to power 4. Now things are very simple here actually, because a is simply 1 raised to power 4. The very first term gives us a clue right off the bat. It gives us a starting point in some ways. Okay, this is b raised to power 4. Okay, and then plus the second term would become 2 upon, this will become 1 raised to power 4 plus 4 into 2 raised to power 4. Now the third term, now you can write similarly, you can write all the other terms. Now everything has been more or less revealed to you. So now plus now the 10th term would be 10, and then 1 raised to power 4 plus 4 into 10 raised to power 4. Okay, very simple. We have been able to just write it in the Sophie's identity form. We were able to express the denominators. Now with that done, now things become very easy, because we know how to factorize it now. Factorization is essential, because if we don't factorize, how would we separate each term into two fractions? We need to do that. So for that, we should be able to factorize the denominator. Now we can easily factorize the denominator. So how do we go about doing this? So the first term would give us the a. Okay, let us just write the values of a and b here. So a in this case is 1, b is also 1, a in this case is 1, b is actually 2, a in this case is 1, b is actually 3, and last one, what with a is 1 but b is actually 10. Very simple. So now let's just write it. So this first term becomes a plus b the whole square. That's what we need. So we'll have two terms. Okay, the first one will be a plus b, which is 2 squared plus 1 squared, b is 1, a minus b, which is 0 squared plus 1 squared. What about the second one? The second one will be 2 upon, again there will be two terms. Okay, first one is a plus b the whole square plus b square. So a plus b the whole square is of course 3 squared plus b square, which is 2 square. A minus b squared is 1 squared. Okay, and b is 2, so b is 2 square. Now pattern is emerging. Okay, we can already see that the factors are actually common across these, right? So look at this, 1 square plus 2 square. So we don't even have to evaluate it. We can right off the bat, without even writing anything, we can see that one of the terms has to be this, 3 square plus 2 squared, and the next one of course would come from this one. Okay, the a plus b one, which will be equal to 4 squared plus 3 squared. Okay, so we can already see a pattern emerging here, and of course the last one will be, if you want to write it, it will be 10 upon. Okay, so just look at the last term. Okay, so here the third term, there were 3 3s, one was less, other one. So what would happen here is this will be equal to 10 squared plus 9 squared, and then 1 will be more, so which is 11 squared plus 10 squared. Okay, Now from here on, we only need to work on the numerator. So the denominator is kind of factorized. The numerator, we need to express for each of them, we have to express it as a difference of these two factors. That is what. Okay, now things are actually very easy because we know that this is 1 square, 2 square, 3 square. These are just the squares of the numbers. So we know that their difference is actually very nice. Okay, so for example, the difference between these two actually comes out to be 4. Okay, because 1 square would cancel when we subtract it, 2 raised to power 2, which is 4. Similarly, 2 square would actually cancel. This will be 3 square minus 1 square. So the difference that we want in the numerator is actually equal to 3 square minus 1 square, which is 8. This is what we want. We want the difference. And what about the difference between these two? So if we find the difference, 3 square would actually cancel. So this is 4 square 16 minus 4. So this is 12. This is what we want. Okay. And what about here? Okay. So similarly, we can find out. Of course, that is more difficult, but we don't really even have to evaluate that. Okay. So don't even have to evaluate it. Otherwise, we'll have to compute all of these 11 square minus 9 square. Who would want to do that? We don't want to waste time. We can already see a pattern here. This is 4, 8, 12. Okay, we already know what to do here. Is 4, 8 and 12. So what we do is that we take 1 by 4 common. Okay. Then we can write a 4 here. Okay. Then I can express like this: 4 upon 2 square plus 1 square. So what I have done is that I have multiplied each term. So this 2 I have multiplied with 4, this 3 I have multiplied with 4, and I have divided each term with 4 as well. So that is what I have done. Nothing difficult. 0 square plus 1 square, and then plus this is, now I can write here 8 because I have divided by 4, so I can multiply by something here: 3 square plus 2 square into 1 square plus 2 square, plus this I can write it as 12 upon, this will remain the same, 3 square plus 2 square and 4 square plus 3 square. Now I am not writing the last term yet. Okay, but understand that there are more terms here. Okay, but this is done. Okay, now what do? We now try to express this as fraction. Okay, as a difference between two fractions. That is what our ultimate objective is. So this will become, of course the term is positive, so first we'll take the bigger one. So this becomes 1 upon 0 square plus 1 square minus 1 upon 2 square plus 1 square. This is plus, now this will become 1 upon 2 square plus 1 square minus 1 upon 3 square plus 2 square. Now this is the second term. Let's just put more brackets here so that we don't confuse our terms. Okay, so this is like this. Okay, and the next term will be 1 upon, we'll write the bigger one first. Okay, that is the most important thing. This is 3. Okay, so this becomes 3 square plus 2 square minus 1 upon 4 square plus 3 square. Okay, plus there will be more terms here. Okay, I'm not writing the last term yet because I don't really have to. You will just see in a second. Okay, and then we will have the closing of the larger bracket. Now if you notice, we have achieved success. So this term and this term actually cancel, this term and this term actually cancel, this term and this term actually cancel. So this sum is reduced to 1 by 4 into 1. This is just 1 minus the last term which will come from here. Now what is the last term which will come from here? The term which will come from here will actually be the smaller one. Okay, because the bigger term would actually get the cancelled. So the negative term is the smaller one. Now the smaller one has to be 11 square plus 10 square. Very simple. Okay, and all other terms actually get cancelled. Now 11 square we know is 121, 10 square we know is 100. So this becomes 1 by 4 into 1 minus 1 by, this is 221. Okay, very simple. Then this becomes 1 by 4 into 220 divided by 221. Fortunately, see, one of the things that had been asked here is that m and n are co-prime. What does it mean by m and n are co-prime? That means that there are no common factors. So all that is saying, the question is saying, is that we need to reduce this further. We need to cancel all the common factors between the numerator and denominator. That is what it is saying. We have to express this fraction in the smallest terms, if you will. That is what this is saying. So this becomes 5 and this becomes 555. Now it is no more simplifiable, because the denominator does not have a factor of either 5 or 11, which are the factors of the numerator. So this is now m and n. So m is equal to 55, n is equal to 221. So we have to find their sum. So this becomes 5 plus 1 6, 5 plus 2 7. And then becomes 276, and that is our final answer. Okay, so again, very simple problem, provided we knew the Sophie Germain's identity. And of course, without actually being able to solve this problem, you cannot get 100 on 100, you cannot get full marks. We will be looking at many such things which actually create 1 mark, 1 question difference between the ranks here. Okay, and some of those things are like Chebyshev's polynomial. Now, those are very important. Now, tricky questions on binomial theorem. Now, those are of course very important, because these questions are asked regularly to distinguish the very best candidates from the those who have actually not studied these things. So typically the Olympiad kind of students. Okay, so do subscribe. We'll be looking at those, and of course on Doorstep Tutor we will be solving many such questions. Thank you.